Hi everyone, this is the B4C4P4 Foundation Past Paper 1 run-through. Remember, you always have these equations at the front of your booklet. Use them in the physics section in particular. So the first section is the biology section. So first question, humans treat food in different ways to stop decay. Some examples of traditional methods shown on the table, so different types of food, the country they're in, and the different ways they stop them from rotting, which is what decaying means, really. It says, when adobo is made, which substance is added to the meat to stop decay? So adobo's here, it says meat is mixed with vinegar, garlic and bay leaves. So they basically want you to work out which one of these is stopping the rotting, and that is vinegar. And then a modern way of preserving milk is to remove all the water. One food in the table is preserved using the same idea, write down the name of this food. So removing the water essentially means like drying it out. So if you look at these four, the one that's being dried out is the fish that are left hung up in the open air. So bumalo is your answer there. And then most methods of food preservation stop microorganisms from working. Write down one type of microorganism that decays food. So you could put bacteria or fungi, or you could put mould, would also be fine there. And how are microorganisms useful in treating human waste? So Mark's here for saying used to break down or decompose or digest. You could say to decays or it rots. Sewage. So the human waste, so it rots or decays a human waste, or it breaks it down or decomposes it or digests it. Next question, Katie cuts 2 chips from a potato. She puts one of the chips into a test tube of distilled water. Katie puts the other chip into an empty test tube. Water enters the cells of the potato chip that has been left in the distilled water. Explain how. So first you've got to use the keyword osmosis. So it's by osmosis that this happens. And then the second mark is where it goes through, and that's through the cell membrane. So it happens via osmosis, and it travels through the cell membrane. Katie takes a potato chip out of the empty test tube. She measures how much it bends. To do this, she pins the chip to a cork. Katie then measures how much it bends using a protractor. Katie then measures how much the chip from the distilled water bends. The chip that's been in the distilled water does not bend. Explain why. So the first mark is the idea that the cells are full of the water that it's been in. So cells are full of water, or you could say the cells are rigid, or you could say the cells are swollen. You could say the cells are turgid, or it has turgid pressure. And then the final mark is the idea, a description of what turgid means. So it's the idea that the contents of the cells is pushing against the cell wall, which makes it rigid. So there's actually 3 different things you could write there for the 2 marks. First mark saying the cells are full of water, or the cells are rigid, or the cells are swollen. You could get a mark for saying the cells are turgid. Those are 2 separate marks. And then you could get a mark for describing what turgid means, the idea that the contents of the cell is pushing against the cell wall. Next question, Chris is an organic farmer. He is growing swedes in a field. There are many slugs in the field. The slugs move over the surface of the soil and eat his swede plants. Chris decides to buy some beetles to release into the field. These beetles eat slugs. What name is given to this type of pest control? So this is biological control. So biological is what you want there. And then Chris cannot use pesticides to kill the slugs. Write down the reason why. And that's because if you read the question, you will see that in bold it says that he is an organic farmer. So that's what you need there, just because he's an organic farmer. Okay, so this next question is a 6-mark question. Please can you mark this yourself using the mark scheme that's on the Google site, and then ask your teacher if you'd like to have that checked. Next question, carbon dioxide and water are needed for photosynthesis. Finish the word equation. So carbon dioxide plus water, and that makes glucose and oxygen. It doesn't matter which way round you write those. And then in 1649, scientists thought that plants grew by only taking in soil materials from the soil. Solid materials, sorry. A scientist called Van Helmont did an experiment to test this idea. He grew a tree in a large pot of soil. He measured the mass of the soil and the tree before the experiment, and he measured them 5 years after. And you can see that you've got a 2 kilogram tree added to 100 kilograms of soil, and then you let the tree grow for 5 years, and you've got 80 kilograms of tree and 99 kilograms of soil left over. And it says, explain how Van Helmont's experiment proved the scientists wrong. So this is the idea that you started off with 102 grams of substance and you finished with 179 grams of substance. So some of the mass must have come from elsewhere. So the first mark is the idea that there's not enough mass or materials or substances from the soil, lost from the soil, to supply that gained by the tree. And the second mark is for a calculation, so the idea that the soil lost 1 kilogram but the tree gained 78. Or you could say the total mass changed from 102 kilograms to 179 kilograms. Or you could say if the scientists were correct, then the soil would have been 22 kilograms. Or you could say that the tree has gained 77 kilograms from somewhere else, not the soil. So those are sort of ideas you need to be putting in there for those 2 marks. During the 5 years, Van Helmont watered the soil. Describe how water enters the tree and what happens to the water once it has entered. So 3 marks here. So first mark saying that it enters through the roots. You could say by osmosis for another mark. You could say that it's transported up the stem for a mark. You could say it passes through the xylem for a mark. You could say it's lost from the leaves by evaporation for a mark. And then you could use the keyword by the process of transpiration for a mark as well. So 6 different things you could have said there for those 3 marks. Van Helmont thought the tree gained mass only from water. 50 years later, another scientist tested this by growing plants in water without soil. What name is given to growing plants in water without soil? So that's hydroponics. I'll just spell that out for you. Hydroponics is the idea of growing plants without soil, but just with water. And the scientist grew one set of plants in distilled water. He grew another set in distilled water that had a small amount of soil added to it. The plants grew better in the water that had some soil. Explain why. So this is the idea that soil contains minerals or nutrients, and that the minerals are needed for plant growth. Or the idea that without the minerals, the plants do not grow as well. So we're on to the chemistry section. So first question, the table shows the electronic structures of the atoms of some elements. So there they are. How many electrons are there in one atom of chlorine? So here's chlorine, and this tells you how many electrons are in each shell of the atom. If you just add them up, that gives you the total number of electrons in one atom. So that is 17, which is 2 plus 8 plus 7. What is the atomic number of magnesium? Well, the atomic number is the same as the number of electrons in an atom of it. So again, just add up number of electrons in magnesium, so that is 12, 2 plus 8 plus 2. Write down symbols for 2 elements in the same group of the periodic table, choosing the table above. So elements in the same group have the same number of outer electrons. So the last shell will have the same number of electrons. So you could have had magnesium and calcium, because they both have 2 in the last one. Or indeed, you could have had helium and neon, actually, if you look at the periodic table, because they're in the same group if you look at the periodic table, but it's easier just to look at the number of electrons in the outer shell. So you've got magnesium and calcium. Write the symbols of 2 elements in the same period. So that in the same period, they have the same number of shells, so the same number of numbers, if you like, in electronic structure. So oxygen and neon are in the same period, or you could have had magnesium and chlorine. So they've both got 2 shells, and magnesium and chlorine have both got 3 shells, so either one of those pairs. In 1808, a scientist named Dalton published his atomic theory. Dalton thought that elements were made up of atoms, and atoms could not be split into simpler particles. About a century later, a scientist called Rutherford published another atomic theory. Rutherford thought that atoms had a positively charged nucleus, and electrons orbited the nucleus. Why is it important that scientists publish their theories? So, 2 marks here, and there's 4 things you could say. You could say so that results can be replicated. You could say that so further evidence can be collected, or the theory can be developed. You could say that it could be so it can be checked by other scientists, or you could say so scientists get the credit that they deserve for it. Next one, write about one difference between Dalton's atomic theory and Rutherford's atomic theory. First thing is that Rutherford's theory, the atom can be split, and in Dalton's theory, atoms could not be split. So that's the idea there. And what is the electrical charge on an electron? That is negative. You could also put -1 if you wanted to, or just minus, indeed. Next question, lithium is in group 1 of the periodic table. Lithium is stored under oil in a sealed bottle. Explain why lithium is stored under oil. So this is the idea that it reacts quite readily with the air and water. So first mark, you can say it reacts with water, and therefore it can't be stored in water, and it also reacts with oxygen as well. So it reacts with water for first mark, and it reacts with oxygen for the second mark. This next question is the 6-mark question, so please mark this yourself using the mark scheme that's online on the Google site, and then ask your teacher to check it if you're unsure whether you've marked it correctly. Next question, Oscar investigates the thermal decomposition of zinc carbonate. He heats 4 grams of solid zinc carbonate for 30 minutes in a hot oven. He lets the solid cool down and then measures its mass. He repeats the experiment 4 more times. Each time he uses a different oven temperature. Oscar makes a prediction, and there's his prediction. He says the higher the oven temperature, the greater the mass of carbon dioxide made. And he's got some results there, and it asks you whether they support his prediction. So there's no mark for saying yes or no, but if you put yes, you need to say that as the temperature increases, the mass decreases. So you can see here that as the oven temperature increases, the mass of the solid after heating decreases. And then you need to say why that matters. So the lower the mass of the solid, the more carbon dioxide that must be made, because if you look back at the equation, here's the solid he's starting with, and here's the solid he's going to be ending with. Carbon dioxide is made, so whatever is lost from the solid after heating, that must be carbon dioxide. So that's one way you could look at it. The other way you could look at it is you could say no, because after 500, the mass no longer decreases. So you could also get the 2 marks for saying that. Oscar wants to check that carbon dioxide is being made in the reaction. What's the chemical test for it? So lime water, first mark, and it goes milky or gives a white precipitate, or goes white, misty, cloudy, or creamy for the second mark. Most metals have high melting points. Look at the graph, it shows the melting points of some metals. There they are. Write the symbol of a metal that can be used to make a container to melt iron. Explain your answer. So, if you want to melt iron, then the melting point of the metal you're going to put it in needs to be higher than the melting point of iron. So there's iron. So you could use these 3 here. So it's going to be titanium, vanadium, or chromium. So you get 1 mark saying one of those, and the second mark is for saying that they have melting points that are higher than the melting point of iron. Write the symbol of metal that's the weakest metallic bonds. So if they have the weakest metallic bonds, it's going to have the lowest melting point. So that's potassium, or if you put K, that's fine as well. And then one property of metals is that they often have high melting points. Write about other properties of metals. So you've got a whole list of things you could say here, so listen carefully. You need any 2 of these. You could say high boiling point. You could say that it conducts heat. You can say it conducts electricity. You can't just say it's a good conductor. You need to say what it conducts. It has a high density. It's flexible, or it can bend, or it's malleable. It's ductile. It's lustrous or shiny. It's hard. It's strong. And it has basic oxides. You could say it's alkaline oxides. You could say it forms positive ions, and you can say it forms ionic compounds. So any 2 of those, that long list, will get you those 2 marks. Now onto the physics section. Ultrasound is a longitudinal wave. Look at the diagram of a longitudinal wave. Choose from A, B, C, D, or E to complete the following sentences. So it says that wavelength is a distance between letter and letter. So it's between letter A here and D here. So that's one wavelength, because it's going from, it looks the same at A and D. So letter A and D. And then rarefaction is shown by letter B. Alfie has stones in his kidney. The doctor used an ultrasound machine. Suggest why doctors use ultrasound before they operate. So this is just to find the position of the problem, or to find out where the stones are. That sort of idea will get you that mark. Write down one other use of ultrasound. So to scan the body, or pregnancy scan would be fine there. You could also say to check for cancer or tumour. You could say to break the kidney stones down. You could also say for testing for cracks in metals. say for dog whistles or cat scarers. So any of those will get you that mark. A radioactive tracer is put into an underground water pipe. A detector above the ground measures the radioactivity. The graph shows the amount of radioactivity detected along the length of the pipe. So there's the graphs. Oh, sorry, this is the 6-mark question. So if you could mark this yourself and then ask your teacher if you are unsure whether you've marked it correctly. Ronan and Curie used an electric circuit to investigate the resistance of a thin wire. Ronan changes the length of the wire. He calculates the resistance for each length. He plots a graph of the results. Use the graph to estimate the resistance when the length of the wire is 1 metre. So the first thing you've got to do is extend the line. So you've got to do this carefully and with a ruler, but I haven't got a ruler obviously, so I'm just going to do it freehand. There we are. And then you've got to read off the graph at 1 metre. So there's 1 metre. Read across, so that's where it hits there. So I get 5.4. Now if you use a ruler, just see what the mark scheme says. Yeah, if you use a ruler, what you should get is between 4.8 and 5.2. That's what will get you both of those marks. So any number between 4.8 and 5.2, 5.4 wouldn't get you the mark because I haven't used a ruler here, which is why I got slightly higher than the mark scheme. Ronan repeats the investigation with a thicker wire. Here is results, there they are. Put a ring around the correct answer, so that is 0.63 ohms. So remember, V equals IR. You can see this on your formula sheet at the front. So then you've got to rearrange that to get resistance. So resistance equals voltage over current. So dividing the voltage by the current gets you that number. Curie writes a 2-sentence conclusion. So there's a sentence 1, as the wire gets thicker, the resistance decreases. Sentence 2 is because there is less current flowing to the wire. Is Curie's conclusion correct? So first mark here is saying that the first sentence is correct, or saying that sentence 2 is incorrect. And the second mark is saying that the resistance is lower, so current is higher. So you need to say that which one is incorrect. So sentence 2 is incorrect, and then correct it. So first mark is saying the sentence 2 is incorrect, or the first sentence, or only the first sentence is correct. And the second mark is saying that when the resistance is lower, the current is higher. A dimmer switch can be used to control the brightness of a light in a room. One type of dimmer switch contains a variable resistor. Describe how the variable resistor in this dimmer switch can reduce the brightness of the light. So turning the switch increases the resistance. You've got to use the word resistance there. So that's your first mark. Turning the switch increases the resistance. And then that decreases the current for the second mark. This question is about nuclear energy. Complete the crossword. Okay, so a fuel used in a nuclear power station is uranium. Is your first one there, uranium. Now you can put this either in the crossword or you can put it on the answer up here. The second one down, energy from reactors used to heat water, turning it into steam. And then last one, the waste produced by a nuclear reactor is, and that's a long word there, I assume it is radioactive. Let's just check it fits. Yes, it does, radioactive. If you got 1 or 2 of those correct, it's 1 mark. If you got all 3 correct, it is 2 marks. Next question, scientific ideas can be shown by models. Look at a simple model for nuclear fission. Describe the process of nuclear fission using this simple model. So, first mark is saying that the nucleus splits, or it breaks up, or breaks down, or it divides. And then the second mark is saying that then gives 2 nuclei. So, this splits to give 2 nuclei. There's your 2 marks. Tanida jumps up and down on a trampoline. The jumping surface of the trampoline is an insulating material. Tanida is wearing synthetic socks. When Tanida gets off the trampoline, she gets an electrostatic shock as she touches the ground. Explain why Tanida gets an electrostatic shock. So, first mark saying that Tanida has become charged, or she's gained electrons, or she's lost electrons, or she has become positive. And the second mark is saying that she is earthed when she gets off the trampoline. Or that you can say the charge flows to Earth when she gets off the trampoline. Or Tanida becomes neutral, or she loses the charge. So last question, Tanida's parents want to reduce her risk of an electrostatic shock. Look at the information they found on the internet. So there's some information, the probability of electrostatic shock, and then how to reduce the risk. So suggest which change to make to reduce the risk the most. Describe how this method works. So the method that has the lowest probability is the one that's going to reduce the risk the most. So putting this down as your answer is going to get you the first mark. Only use the trampoline where there is moisture in the air. The second mark is saying how that works. So you can say that moisture conducts, or the static can't build up for the second mark. So add up your marks and put them in your poster. Your magic number is 40. If you're getting more than 40 marks, then that is a C. And now try the next one.